Today, ladies and gentlemen, I will finish my text parser by making sure it can work with any files of any size. And in order to do that, I'll have to talk a bit about memory management. Because right now I have all of these static arrays everywhere, and that's fine, I like static arrays, but they have limitations. Chief among them, they can't be too large. Let me show you. Say I create 1,048,576 tokens, just a random large number, and then I run this, and then my program crashes as soon as it enters main. If you look at the call stack, you can see that it actually goes wrong in the function checkstackmiss. And checkstackmiss, I'm pretty sure, stands for checkstack Microsoft. And it checks if there's enough room available on the stack. And there isn't, because the stack is no larger than a few megabytes. Now, the solution is quite simple. I need to create the memory on the heap, and I use a function called calloc for that. It will return a pointer, and it takes two arguments. The first one is how many tokens I need. Let's go with that same number again. And the second is how large each token is in bytes. Calloc will allocate the memory, zero it out, which is important, and then return the pointer. And this runs without problem, no memory errors. Now, because I allocated the memory myself, I also need to free it myself. So first, I need to determine how long I need it. And I use tokens in the tokenizer, of course, in the parser, and in the memorizer. But after that, I don't need them anymore. The get function works fine even if I release the tokens. So I do that here, and all I need for that is to call free and pass it the pointer. That's all there is to it. Mind that it's still possible to run out of memory, but you'd have to be dealing with a huge ini file. Still, I should check for that. If I run out of memory, then calloc will return a null pointer. If that happens, I'll exit the program. There's not a whole lot else I can do. Of course, another big benefit of dynamic allocation is that I can now determine at runtime how many tokens I want to allocate. I mean, I don't really need 1,048,576 tokens. If only I could figure out how many tokens I do need without running the tokenizer. But don't worry, I have a plan. I will loop over all the characters in the ini text one by one. If a character is a square bracket or an assignment operator, I up the token count by 1. If a character is a letter, then I'll skip all the letters that follow it and up the token count by 1. Any other characters, I'll just skip. And that's how I count tokens. I'll put this in a separate function. I'll start at the first character, the count starts at 0, then loop until I reach the end of the string. If the character is a square bracket or an assignment operator, I increase the count and go to the next character. If the character is a letter, I'll skip over all subsequent letters and increase the token count. If the character is anything else, I just skip it. Return the result. Okay, to use that function, I just need to call it. Then I plug in the result here and also here because that's not static anymore. Now, if I run this, the maximum number of tokens is exactly the actual number of tokens, and there are no tokenizer errors. Very nice. Speaking of tokenizer errors, I could use dynamic allocation for those as well, but I'm not gonna. Thing is, there's no way to know beforehand how many errors I will run into. Also, I can report like millions of errors, but you're only going to read the first handful anyway, so it's fine if the number of errors is limited. I'll just up it to something largish, and I'll do that for all types of errors, and that should be fine. Next up is the sections array. Can I find out how many sections I have? Well, yes, I think I can. See, the thing about sections is, you can't have a section header without square brackets. So if I just count the number of start header tokens, I know how many sections I have. So I create a function that receives the tokens. Now, the section count starts at 1 because I always have the default section. And then I need to iterate over the tokens, which is easy because I have my token iterator. Okay, if the current token is a start header token, then I increase the section count. That's it, just return the result. And now I can use it here. Allocate the memory. Change this. And since I allocated memory, I also have to free it. The memorizer still needs the sections, but get doesn't. All that's left is to handle out of memory. But I need to be a bit more careful here. See, I already allocated the tokens. But now I'm not going to use them anymore, so I should free them. Okay, assignments is going to be pretty similar. You can't have an assignment without an assignment operator, so I'll just count those. Cool. Create the function. This time the count does start at 0, there's no such thing as a default assignment. You know the iterator stuff by now. If the token is an assignment operator, up the count. And now I can use it. When I go out of memory, I now need to release both the tokens and the sections. Replace this. And don't forget to release the memory. Let's check the parser, see what we have. Sections 3 out of 3. Assignments 4 out of 4. Parse errors none. Splendid. The entry count is dead simple because the number of entries is always the same as the number of assignments. If I go out of memory, I need to release tokens and sections and assignments. Update the max size. Of course, the entries are part of the settings struct, and the settings get passed to the get function, so I can't release them here. I need to release them after I'm done with everything to do with the ini data. The settings struct doesn't just contain entries, it also contains the string buffer. Now, how am I going to determine the size of that? Well, the string buffer contains all text tokens, and for all text tokens, it adds a null character. Now, the size of a token isn't hard to determine. I just subtract the start index from the end index. So I just have to iterate over the tokens again. I will start the buffer size at 1 because I always have a default section, but there is no token for that one. The name of the default section is the empty string, which is just a single null character, hence the size of 1. Then the iterator again, nothing new there. Okay, if the token is text, then I increase the size by the size of the token. Plus 1 for the null character. I'll need to update the settings struct, get rid of that static array. And I will also add the buffer size because the memorizer still uses max buffer size, and I want to get rid of that. I hope you are duly impressed by the fact that I remember that, because it's certainly not a bug I ran into and then cut from the video. Then allocate the buffer here. If I go out of memory, release tokens, sections, assignments, and entries. Initialize the settings. And remember to free the buffer when I don't need it anymore. Well, is this going to be the final run? 4 entries out of 4, that's a good start. The buffer is 75 characters large. Let's see if I can inspect the contents. Immortality, forever, editor, font, monospace, color, white, terminal, visible, on. Everything is there. Okay, Well, let's run the get function too. Yeah, that's exactly as it should be. Good, good, good. Free the memory. And now it's all garbage. Splendid. Well, ladies and gentlemen, that's it. I'm happy with this text parser. If there are some features you want to add still, you should have all the information you need, so just give it a go. And if you have a question, just leave a comment. I'll do my best to help. Thanks so much for watching, and a special thanks to my Patreon supporters. See you next time. Now go do some coding. Because it's fun.